Hello, in this lecture we'll answer two questions. In the first question, we'll find out the radius of this circle, and in the second question, we'll find out the area of this green shape. So we'll start with the first question. In the drawing, we have a circle. From the current standpoint, point A, we have two tangents to this circle, tangent AQ and tangent AP. Likewise, we have the third tangent to this circle, tangent BC. This is tangent to this circle, this point. So we define the touching point of tangent BC with this circle. This point is point M. We define the center of this circle. This point is point O. In addition, we know that AB equals to 16 units in its length, AC equals to 18 units in its length. Again, our task is to find out the radius of this circle. So we define the radius of this circle as R. Point Q is the point of tendency of tangent AQ with this circle. So in the next step, we join points O and Q together by a straight line. Point O is the center of the circle, point Q is the point of the circle itself, therefore Q is the radius of this circle, equals to R. The radius of Q that is equal to R, the radius of Q is drawn to point Q, that is the point of tendency of tangent AQ with this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent AQ will be perpendicular to the radius QO. If AQ is perpendicular to QO, it means that this angle equals to 90 degrees in size, according to rule 1. Likewise, we will join points O and P together by a straight line. Point P is the point of tendency of tangent AP with this circle. So OP is the radius of this circle, equals to R. The radius OP is equals to R is drawn to point P, that is the point of tendency of tangent AP with this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent AP will be perpendicular to the radius PO. If AP is perpendicular to PO, it means that this angle equals to 90 degrees inside, according to the same rule, rule 1. Here we can implement also rule 2. Now drawing. So click on rule 2. According to rule 2, the lengths of two tangents from common standpoint to a circle are equal. In the drawing, we have a circle. This is the common standpoint, point P. From this common standpoint, point P, we have two tangents to this circle, tangent PA and tangent PB. According to this rule 2, they are equal to each other. That is to say, PA equals to PB. So we can actually implement rule 2 in our drawing. So first of all, we define the length of this short line segment BP as X. BP equals to X according to our definition. For this common standpoint, point B, we have two tangents to this circle, tangent BM and tangent BP. And according to rule 2, they are equal to each other. That is to say, BP equals to BM. But BP equals to X, therefore BM must also equal to X units in its length. What is the length of this short line segment MC? From the drawing, it is very easy to see that MC in total equals to BC minus BM. As you know, MC equals to BC minus BM. So MC equals to BC, that is 14 according to what is going to the question, minus BM. BM is X. So we found out that the missing answer MC equals to 14 minus X units in its length. The next step, we focus on this common standpoint, point C. From this common standpoint, point C, we have two tangents to this circle, tangent CM and tangent CQ. And according to rule 2, they are equal to each other. That is to say, CM equals to CQ. But CM equals to 14 minus X, therefore CQ must be also equal to 14 minus X units in its length, according to rule 2. So CQ equals QC equals to 14 plus x units in its length. In the next step, we'll focus on this connector point, point A. For this connector point A, we have two tangents to this circle, tangent AQ and tangent AP. And the two are equal to each other. That is to say, AP equals to AQ. So I'll write it down. AP equals to AQ according to all two. AP equals to 16 plus x. Let it know. Likewise, AQ equals to QC, that is 14 minus 6, plus C8, that is 18. So in total, QA equals to 14 minus 6 plus 18. Those two sides of the equation are equal to each other. That is to say, 16 plus x equals to 14 minus x plus 18. So 16 plus x equals to 14 plus 18 is 32 minus x. So in total, we know that 16 plus x equals to 32 minus x. Here we add x to this equation and get that x plus x is 2x. So in this side of the equation, we have 16 plus 2x equals to 32. Here we subtract 16 from this equation, and we get that 2x equals to 32 minus 16 is 16. So 2x equals to 16. Here we divide this equation by 2, and we get that x equals to 16 over 2, that is 8. X equals to 8 units in its length. PB equals to x, and x is equals to 8. Likewise, BM equals to x and x equals to 8. Here we have MC equals to 14 minus x. 14 minus x is 14 minus 8, that is 6. Likewise, QC also equals to 14 minus x, that is 6. In the next step, we will join points A and O together by a straight line. By joining points A and O, created here two right triangles. This is the upper right triangle APO, and this is the lower right triangle AOQ. And the area of this quadrilateral APOQ must be equal to the sum of the areas of those two components that it consists of. That is to say, the area of quadrilateral APOQ must be equal to the area of the first component that it consists of. This is the area of the right triangle APO plus the area of the second component that quadrilateral APOQ consists of. That is the area of this lower right triangle AOQ. So it is now the area of this quadrilateral APOQ must be equal to the sum of the areas of those two components that it consists of. This is the first component that quadrilateral APOQ consists of. This is actually the right triangle APO plus the area of the second component that quadrilateral AP or Q consists of. This is actually the area of this lower right triangle A or Q. So in total, the area of quadrilateral AP or Q equals to the area of this upper right triangle APO. We will choose the base as AP. And the height of the base is PO because it's greater than 90 degrees with the base. So the height is PO over 2. So if you know that the area of this upper right triangle APO equals to the base AP times the height PO over 2. Likewise, the area of this right lower triangle OQA equals to the base AQ times the height to the base that is OQ, because it's greater than 90 degrees with the base, so times the height to the base that is OQ over 2. So if you know that the area of quadrilateral AP or Q equals to the area of the triangle APO, that is actually equals to the base AP. AP equals to 8 plus 16, that is 24. Again, AP equals to PB, that is 8, plus B8, that is 16. So in total, AP equals to 16 plus 8, that is 24. Times the height PO. PO equals to R, it is the radius of this circle. This is the radius that we are looking for in this question. Over 2. So total, the area of the right upper triangle APO equals to 24 over 2. Plus the area of the right triangle AOQ is equals to the base OQ. OQ equals to QC, that is 14 over 6. Plus that's actually 6, QC that is 6, plus C8 that is 18. So total QA equals to 18 plus 6, that is 24, times the height to the base that is R over 2. So total we found out that the area of quadrilateral AP or Q equals to 24 R over 2. 24 over 2 is 12, so in total this expression equals to 12R. And here we have 24 R over 2, so it's actually 24 over 2 is 12, so total this expression also equals to 12R. 12R plus 12R is 24R. So total we found out that the area of quadrilateral AP or Q is equal to 24R square in size. The next step, we'll join points on B together by straight line. And we'll join points on C together by straight line. By doing those constructions, we get there 1, 2, 3, 4 right angles. Actually, this right side OM is the radius of this circle, equals to R. OM equals to R. And point M, this is point M, that is the point of tendency of tangent BC with this circle. The radius OM that is equals to R, the radius OM is known to point M, that is the point of tendency of tangent BC with this circle. Whenever you have a radius that is known to the point of tendency, then this BC will be perpendicular to the radius MO. If BC is perpendicular to MO, it means that this angle equals to 90 degrees in its size. This angle also equals to 90 degrees in its size. Turning to the same rule 1. So actually, by doing all those constructions, we can do 1, 2, 3, 4 right angles. So the area of this quadrilateral APOQ equals to the sum of those 4 right angles plus the area of triangle ABC. But again, the area of this quadrilateral APOQ equals to the sum of those 4 right angles plus the area of this triangle ABC. So it is now the area of quadrilateral APOQ equals to the area of this first right angle is actually equal to the base PB, that is 8, times the height PO over 2. So total the area of this right triangle OPB equals to 8R over 2. 8R over 2 is 4R. Likewise, the area of this triangle OBM equals to the base BM, that is X, times the height MO, that is R over 2. So total the area of this triangle BMO equals to 8R over 2, that is actually 4R. Plus the area of this right triangle OMC is equal to the base MC, that is 6, times the height R over 2. So in total, the area of this triangle OMC equals to 6R over 2. 6R over 2 is 3R. Plus the area of this right triangle OQC. The area of the right triangle OQC equals to the base 6 times the height R over 2. So in total, the area of this triangle OQC equals to 6R over 2, that is 3R. Therefore, the area on those all 4 triangles is equal to 4R plus the area of this triangle OMB, it is also 4R, plus the area of this triangle OCM, that is 3R, plus the area of this triangle OQC, that is 3R. So we actually found out that the area of those 4 small right triangles, in total, the sum of the areas of those all 4 small right triangles equals to 4R plus 4R is 8R, 8R plus 3R is 11R, 11R plus 3R is 14R. But then, the sum of the areas of all those 4 small right triangles, in total they are equal to 14R square in size. Plus the area of this triangle ABC, total the sum of those 5 components, this is the area of the big quadrilateral APOQ. So plus the area of this triangle ABC is equal to the area of quadrilateral APOQ. But again, quadrilateral APOQ in total consists of 5 components. 1, 2, 3, 4, 5. The sum of those of the areas of those 4 components in total is 14R, plus the area of triangle ABC. In total, it is the area of all those 5 components of quadrilateral APOQ. So in total, the area of quadrilateral APOQ equals to the sum of the areas of the 4 right triangles, that is 14R, plus the area of triangle ABC. So the only thing that is left to do is to find out the area of this triangle ABC. So what is the area of triangle ABC? We have a special formula for the area of any triangle. The area of any the area of any triangle equals to the square root of s times s minus a times s minus b times s minus c. S is the semiperimeter of triangle ABC. The semiperimeter S is the perimeter over 2. And again, the semiperimeter S is the perimeter over 2. And the perimeter of this triangle ABC equals to the sum of its 4 side lengths. It's actually 16 plus 14 plus 18. The perimeter in total is equals to 16 plus 14 plus 18 over 2. Over 2 is the semi-perimeter. 16 plus 14 is 30, and 30 plus 18 is 48 over 2. 48 over 2 is 24. So total, we found out that the semi-perimeter of this triangle ABC, S equals to 24 units in its length. A, B, and C, this equation, are the side lengths of triangle ABC. It shows BC is equals to 16 SA, so A equals to 16. We choose B as BC, this is 14, so B equals to 14. And finally, we choose C in this equation as C8 is equals to 18. So C equals to 18. So we have all the data that is needed in order to find out this triangle ABC. You just have to put the data of our specific triangle ABC inside this general formula for the area of a triangle. This way we find out the area of this triangle ABC. So the area of triangle ABC in total equals to the square root of S is 24, times S minus A. S is 24, and A is 16, times S minus B. S is 24, and B is 14, times S minus C. S is 24, and C is 18. So today we found out that the area of triangle ABC is equal to the square root of 24, and 24 minus 16 is 8, times 24 minus 14 is 10, times 24 minus 8 is 16. So today we found out that the area of our triangle ABC equals to the square root of 24 times 8 times 10 times 16. This expression in total is equal to 107.33 square root in size. So in total, if you found out that the area of triangle ABC is equal to 107.33 square root in size. The area of this triangle ABC equals to 107.33 square root in size. Our task is to find out the radius of this circle. We create an equation that says that the area of this quadrangle A, P, or Q according to the first method of calculation. Found out that the area of this quadrangle A, P, or Q according to the first method of calculation is 24 r square root in size. Must be equal to the area of this quadrangle AP or Q according to the second method of calculation. Okay. repeat again, the area of quadrilateral APOQ according to the first method of calculation, although it is 24 arcs components in size, must be equal to the area of the same quadrilateral APOQ according to the second method of calculation. Okay, again, the area of triangle APOQ according to the first method of calculation is 24 arcs components in size. It must be equal to the area of the same quadrilateral APOQ according to the second method of calculation. The area of quadrilateral APOQ according to the second method of calculation is equal to 14R plus the area of triangle ABC, it is 107.33 squares in size. So in total, we found out that the area of quadrilateral APOQ according to the second method of calculation equals to 14R plus 107.33. R plus 107.33. Here we'll subtract 14R from this equation. And get that inside the equation we have 24R minus 14R is 10R. Here 14R minus 14R is 0, so we have only 107.33. Here we divide this equation by 10. And when we get that the radius that we are looking for this equation, the radius R equals to 107.33 over 10 is 10.733 units in its length. And again, we found out that the area that we are looking for this question, that is the area, the radius that we are looking for this question, that is the radius of this circle, equals to R, is equal to 10.733 units in its length. So we finish with the first question. In the next step, I present you the second question and we solve the second question of this lecture. In the second question, our task is to find out the area of this ring shape. So in the drawing, we have three semicircles. This is the biggest semicircle, this is the medium semicircle, and this is the smallest semicircle. In addition, we have this quarter circle and this rectangle. And we know that the area of this rectangle is equal to 4 square units in its length, in size. Again, our task is to find out the area of this ring shape. So first of all, we will define the length of this rectangle. This length is x. And we will define the width of this rectangle. This segment is y. And the length is x, and the width is y. We know that the area of a rectangle equals to the length times the width. Therefore, the area of this rectangle must be equal to the length x times the width y, that is x times y equals to 4. This gives us the equation that the area of this rectangle is equal to 4 square units in its size. That is to say, the width of the rectangle that is x, the length of this rectangle that is x times the width y equals to the area of this rectangle that is 4 square units in its size. Okay? So I found out that x times y equals to 4. So here we have the rule that the opposite sides of a rectangle are equal to each other. So the this side equals to the opposite side, but this side is y, therefore the opposite side must be also equal to 1 unit in its length. We know that this is a quarter circle. Therefore, those two line segments are the radii of the quarter circle. We know that the radii is y, so this is also the radii. This must be also equal to y. And again, those two line segments, they are both the radii of the quarter circle. So this radii equals to y, and therefore the other this radius equals to y, and therefore the other radius must be also equal to y. Okay, so what is the radius of this biggest semicircle? The radius of the biggest semicircle equals to the diameter over 2. And again, the radius of this biggest semicircle equals to the diameter over 2. So the radius of the biggest semicircle equals to the diameter over 2. The diameter of this semicircle is x plus y. Therefore, the radius equals to x plus y, 2 units in its length. And again, in total, if you found out that the radius of the biggest semicircle equals to x plus y over 2 units in its length. Likewise, what is the radius of the medium semicircle? The radius of the medium semicircle is equal to the diameter over 2. The diameter is x, therefore the diameter over 2 is x over 2. The diameter of the medium semicircle equals to x over 2 units in its length. What is the radius of the smallest semicircle? The radius of this smallest semicircle equals to the diameter over 2. That is to say, it is y over 2 units in its length. Our task is to find out the area of this green shape. So what is the area of the green shape? From the drawing, it is very easy to see that the area of this green shape equals to the area of the biggest semicircle minus the area of the medium semicircle minus the area of the smallest semicircle. Repeat again, the area of this green shape must be equal to the area of the biggest semicircle minus the area of this medium semicircle minus the area of this smallest semicircle. So it is known the area of this green shape equals to the area of the biggest semicircle minus the area of the medium semicircle minus the area of the smallest semicircle. This is the area of the green shape, that is the area that we are looking for in this question. The radius of this biggest semicircle equals to x plus y over 2 units in its length. the radius of this medium semicircle equals to x over 2 units in its length. The radius of the smaller semicircle equals to y over 2 units in its length. The area of the biggest semicircle equals to pi times the radius square over 2. And again, the area of the biggest semicircle equals to pi times the radius square over 2. So it is pi times the radius square. The radius square is x plus y over 2 squared. And again, the radius squared is x plus y over 2 squared. And right, so it is pi times the radius of the circle square, of the semicircle squared over 2. Now the area of the medium semicircle is equals to pi times the radius squared, that is x over 2 squared, divided by 2. Now the area of the smallest semicircle is equals to pi times the radius squared, that is y over 2 squared, divided by 2. So total, the value of this expression equals to the area of the green shape, that is the area that we are looking for in this question. So we'll simplify all those three expressions. So here we have pi over 2 and x plus y over 2 squared. X plus y squared is x squared plus y squared plus 2 times x times y over 2 squared. 2 squared is 4. So in total, the value of this expression is pi over 2 times x squared plus y squared plus 2xy over 4. So here we have pi over 2 and x over 2 squared equals to x squared over 4. Minus pi over 2 times y over 2 squared is y squared over 4. So here we'll take 8 as a common factor out of those three expressions. In the denominator we have 8 in all those three expressions, so 8 will be taken as a common factor of those three expressions. So here we have pi times x squared plus y squared plus 2xy. So it is pi times x squared is pi x squared. Pi times y squared is pi y squared. Plus pi times 2y is 2 pi xy. And we have minus pi times x squared is minus x squared, minus pi times x squared is pi minus pi x squared. We have minus pi times y squared is minus pi y squared. Pi y squared minus pi x squared minus pi x squared is 0, so those two expressions will get cancelled. Pi y squared minus pi y squared is 0, so those two expressions also will get cancelled. And we're left only with 2 pi xy over 8. Here we divide both the numerator and the denominator of this expression by 2. So 2 over 2 is 1, so inside here in the numerator we're left only with pi x squared, and 8 over 2 is 4. So today we found out that the area of this green shape equals to pi times xy over 4. So it is pi over 4 times xy. And we found out that xy equals to 4, so we solve xy by 4. Here we have 4 in the numerator, so 4 will get cancelled, and we're left only with pi. So in total we actually found out that the area of this green shape, that is the area that we are looking for, in this question, is equal to pi square units in its size. Again, the area of this green shape equals to pi square units in its size. So we finish with the second question. The next step of the lecture, we start with the repetition the repetition of the first question, and then repeat on the solution of this second question. Our task in the first question is to find out the radius of this circle. So we're drawing a circle. From point A, we have, from the common point A, we have two tangents to the circle, tangent AB and tangent AQ. Likewise, we have a third tangent to this circle. This is tangent BC. AC equals to 18 units in its length, AB equals to 16 units in its length, BC equals to 14 units in its length. Again, our task is to find out the radius of this circle. So first of all, we find the touching point of tangent BC with this circle, or the point of tendency of tangent BC with this circle. This point is point M. We define the center of this circle. This point is point O. We define the radius of this circle as R. The radius of the circle equals to R according to our definition. In the next step, we join points O and Q together by side line. Point O is the center of this circle. Point Q is the point of the circle itself. Point Q is the point of the circle itself. Therefore, OQ is the radius of this circle. This equals to R. The radius OQ is equals to R. The radius OQ is drawn to point Q. That is the point of tendency of tangent AQ with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AQ will be perpendicular to the radius QO. If AQ is perpendicular to QO, it means that this angle equals to 90 degrees according to rule 1. Point P is the point of tendency of tangent AP with this circle. The next step, we join points O and P together by side line. OP is of course the radius of this circle, equals to R. The radius of OP is equals to R. The radius of OP is drawn to point P, that is the point of tendency of tangent AP with this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent AP will be perpendicular to the radius PO. If AP is perpendicular to PO, it means that this angle equals to 90 degrees according to rule 1. So, in the next step, we defined this short side PB as X, and we implemented rule 2 in our drawing. A bit quicker on rule 2. According to rule 2, the lengths of two tangents from a common start point to a circle are equal. In the drawing, we have a circle. This is the common start point, point P. From this common start point, point P, we have two tangents to this circle, tangent PA and tangent PB. And according to this rule, all two are equal to each other. That is to say, PA equals to PB. So we can implement rule 2 in our drawing. Why? Because in our drawing, if you focus on this common start point, point P, from this common start point, point P, we have two tangents to this circle, tangent BP and tangent BM. And according to rule 2, they are equal to each other. That is to say, BP equals to BM. But BP equals to X, therefore BM must be also equal to X units in itself, according to rule 2. Likewise, in the next step, we focus on this common start point, point C. But before that, BM equals to X, BC equals to 14. Therefore, the missing line side MC equals to BC minus BM. And again, MC equals to BC minus BM. So, MC equals to BC, that is 14, according to what is the answer question, minus BM, that is X. So total, the missing line side MC equals to 14 minus X units in its length. So in the next time, focus on this common start point, point P, point C. For this common start point, point C, we have two tangents to this circle, tangent CM and tangent CQ. And according to rule 2, they are equal to each other. That is to say, CM equals to CQ. But CM equals to 14 minus X, therefore CQ must be also equal to 14 minus X units in its length. In the next step, we focus on this common point A. From this common point A, we have two tangents to this again. Tangent AP and tangent AQ. And according to two, they are equal to each other. That is to say, AP equals to AQ. And again, actually found out that according to rule 2, AP equals to AQ. AP in total equals to PB, that is x, plus B8, that is 16. So in total, PA equals to 16 plus x. PA equals to 16 plus x, and equal to AP equals to AQ. AQ in total equals to QC, that is 14 minus x, minus, plus C8, that is 18. So in total, QA equals to 14 minus x plus 18. And again, if you found out that QA equals to 14 minus x plus 18. Those two sides of the equation are equal to each other. That is to say, 16 plus x equals to 14 minus x plus 18. Again, 16 plus x equals to 14 minus x plus 18. Here we had that subtracted 14 from this equation. Actually, we have here 16 plus x equals to 14 plus 18 is 32 minus x. So in total, we found out that 16 plus x equals to 32 minus x. Here we added x to this equation. X plus x is 2x. So in this side of the equation, in total, we have 16 plus x. And here we have x plus minus x is 0. So in this side of the equation, we have to only have 32. So in total, we found out that 32 equals to 2x plus 16. Here, subtract 16 from this equation. If I found out that 2x equals to 32 minus 16 is 16. Here we divided this equation by 2 and found out that x equals to 16 over 2, that is 8. So here PB equals to x and x equals to 8. Here BM equals to x and x equals to 8. Here MC equals to 14 minus x, that is to say MC equals to 14 minus 8, that is 6. Likewise, QC also equals to 14 minus x, that is 6. So in the next step, we join points A and O together by a straight line. By joining points A and O, we get that here those two right triangles. We have the upper right triangle OPA and the lower right triangle OQA. Actually, the sum of the areas of those two right triangles is equal to the area of quadrilateral APQO. Because of the fact that quadrilateral APQO consists of those two components, the area of quadrilateral APOQ must be equal to the area of those two, the sum of the areas of those two components that it consists of. And again, the area of the big quadrilateral APOQ must be equal to the sum of the areas of the two components that it consists of. Quadrilateral APOQ consists of those two components. Therefore, it is equal to the area of the first component that it consists of, is actually the area of this upper right triangle APO, plus the area of the second component that it consists of, that is the area of triangle OAQ. And again, the area of quadrilateral APOQ equals to the sum of the areas of the two components that it consists of. That is, it is equal to the area of the first component that it consists of, actually the area of the upper right triangle APO, plus the area of the second component that it consists of, is actually the area of the right lower triangle AOQ. So what is the area of this upper right triangle APO? It equals to the base AP times the height to the base PO over 2. And again, the area of the upper right triangle AP equals to the base AP times the height to the base PO over 2. Plus the area of the second component that it consists of is actually the area of this right lower triangle OQA. The area of this right lower triangle OQA equals to the base AQ times the height QO over 2. And again, the area of the right lower triangle AQ equals to the base AQ times the height QO over 2. So the area of quadrilateral APOQ equals to AP is 16 plus x times the height PO, that is R over 2. So in total, the area, but x equals to 8, so the area of the base AP is 16 plus 8, that is 24, times the height R over 2. So in total, the area of the upper triangle APO equals to 24 R over 2. Now the upper right triangle APO equals to 24 R over 2 plus the area of the lower right triangle AOQ. This is equals to AQ times QO over 2. AQ is 18 plus 6, that is 24, times the height QO, that is R over 2. So total the area of this lower triangle AQO equals to 24 times R over 2. Area of the lower triangle AQO equals to 24 times R over 2. So here we have 24 R over 2 plus 24 R over 2. So 24 R over 2 is 12 R plus 24 R over 2, that is 12 R. So 12 R plus 12 R equals to 24 R. So in total, we actually found out that the area of this quadrilateral APOQ equals to 24 R squared in size. In the next step, we join points on the middle by side line. Likewise, we join points on the middle by side line. This is the radius OM. This is tangent BC. The radius OM that is equals to R, the radius OM is going to point M, that is the point of tendency of tangent BC with this circle. Whenever you have a radius that is known to the point of tendency, then tangent BC will be perpendicular to the radius MO. If BC is perpendicular to MO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. So in total, by doing all those constructions, we can deduce 4 right angles. 1, 2, 3, 4. So what is the area of those? The sum of those all 4 angles, the area of this triangle OPB equals to the base PB, that is 8, times the height PO, that is R over 2. So total the area of this right triangle equals to 8R over 2. 8R over 2 is 4R. Likewise, the area of this triangle OBM equals to the base MB times the height MO over 2. The base MB equals to 8. The height MO equals to R over 2. So total the area of this triangle OBM equals to 8R over 2, that is 4R. Plus the area of this third triangle, right triangle OMC, that equals to the base MC, that is actually 6, times the height MO, that is R over 2. So total the area of this triangle, right triangle CMO equals to 6R over 2. 6R over 2 is 3R. Plus the area of this fourth right triangle, this equals to the base 6 times the height R over 2. So total the area of this triangle equals to 6R over 2, that is 3R. So actually found out that the sum of the areas of those 4 triangles in total is equal to 4R plus 4R plus 3R plus 3R. 4R plus 4R is 8R, 8R plus 3R is 11R, and 11R plus 3R is 14R. So the sum of the areas of those all 4 triangles in total they are equal to 14R squared in size. So in total the area of the quadrilateral APOQ equals to the sum of the areas of those 4 right triangles, that is actually 14R plus the area of triangle ABC. And again, the area of quadrilateral APOQ equals to the sum of the areas of those 4 right triangles plus the area of this triangle ABC. The area of quadrilateral APOQ equals to the sum of the areas of the 4 right triangles, that is actually 14R squared in size, plus the area of triangle ABC. So the only thing that is left to do is to find out the area of this triangle ABC. Use the special formula to find out the area of triangle ABC. The area of triangle ABC equals to the square root of S times S minus 3 times S minus 3 times S minus 3. S is the semi-perimeter of this triangle ABC, and A, B, and C are the side lengths of the triangle ABC. And again, A, B, and C are the side lengths of triangle ABC, and S is the semi-perimeter of triangle ABC. What is the semi-perimeter? Is the perimeter over 2. The semi-perimeter of any triangle equals to the perimeter over 2. The perimeter is the sum of the side lengths of triangle ABC. This is actually 16 plus 14 plus 18. If we divide the perimeter by 2, we get the semi-perimeter. Okay, so in total, the semi-perimeter of triangle ABC equals to the sum of its 3 side lengths, that is actually 16 plus 14 plus 18 over 2. 16 plus 14 is 30, and 30 plus 18 is 48 over 2. 48 over 2 is 24. So in total, if you found out that the semi-perimeter of this triangle ABC equals to 24 units in its length. A, B, and C are the side lengths of this triangle ABC. We choose A is 16, B is 14, and C is 18. We have on the data that is needed in order to find out the area of this triangle ABC. Just to put the data of our triangle ABC inside this general formula for the triangle, on any triangle. In this way, we find out the area of this triangle ABC. So we did it, and we found out that the area of triangle ABC equals to S, that is the semi-perimeter, that is 24, times S minus A. S minus A is 24 minus 16, times S minus B. S minus B is 24 minus 14, times S minus C. S minus C is 24 minus 8. So total, if you found out that the area of triangle ABC equals to the square root of 24 times 20 minus 16 is 8, times 24 minus 14 is 10, times 24 minus 8 is 16. So total, the area of triangle ABC equals to the square root of 24 times 8 times 10 times 16. Actually, the value of this expression in total it is equal to 107.33 square units in size. So if you found out that the area of triangle ABC equals to 107.33 square units in size. The next step, if you had a question that said that the area of quadrangle AP or Q according to the first method of calculation must be equal to the area of quadrangle AP or Q according to the second method of calculation. We already found out that the area of quadrangle AP or Q according to the first method of calculation is equal to 24 r square units in size, and must be equal to the area of quadrangle AP or Q according to the second method of calculation, that is equals to 14r plus 110.33. So here subtract 14r from this equation. So 24r minus 14r is 10r. Here 14r minus 14r is 0. So left only 107.33. So in total, we found out that 10r equals to 107.33. Here we divide this equation by 10 and find out that r, the rest of the circle that we are looking for is equal to 107.33 over 10. That is 10.733 units in its length. Repeat again. We found out that the radius of this circle, that is the radius that we are looking for in this question, is equal to 10.733 units in its length. So finish to repeat on the first solution of the first question. In the next step, repeat on the solution of the second question. In the second question, our task was to find out the area of this relationship. So in the drawing, we have three semicircles. This is the biggest semicircle, this is the medium semicircle, and this is the smallest semicircle. And then, in addition, we have this quarter circle and this rectangle. We know that the area of this rectangle is equal to 4 square units in size. Again, our task was to find out the area of this relationship. So first of all, we define the length of this rectangle is x and the width is y. We know that the area of a rectangle equals to the length x times the width y. Again, the area of this rectangle equals to the length x times the width y. So it is in total x times y, and we know that the area of this rectangle is equal to 4 square units in its size. Therefore, x times y equals to 4. This is the equation, the first equation that we have. So here we have what is the radius of this biggest semicircle. The radius of the biggest semicircle. But before that, we know that the opposite sides of the rectangle are equal to each other. So this side is y, therefore the opposite side must be also equal to y. So this is a quarter circle. Those two sides are the radius of the quarter circle. But this side is y, therefore the other side, this is the second radius of this quarter circle, must be also equal to y. So the radius of the biggest semicircle equals to the diameter x plus y over 2. Repeat again, the radius of this biggest semicircle equals to the diameter, that's x plus y over 2. And again, the radius of the biggest semicircle equals to the diameter xy over 2. Likewise, the radius of this medium semicircle equals to the diameter x over 2. The radius of the medium semicircle equals to x over 2 units in its length. Finally, the radius of this small semicircle equals to the diameter over 2. That is to say, it is y over 2. The radius of the smallest semicircle equals to y over 2 units in its length. Our test. Our task is to find out the area of this green shape. So what is the area of this green shape? From the drawing it is very easy to see that the area of this green shape in total equals to the area of the biggest semicircle minus the area of the medium semicircle minus the area of the small semicircle. Repeat again, the area of this green shape must be equal to the area of the biggest semicircle minus the area of the medium semicircle minus the area of this smallest semicircle. And again, the area of the green shape, that is the area that we are looking for, must be equal to the area of the biggest semicircle minus the area of the medium semicircle minus the area of the smallest semicircle. Now we found out that the radius of this biggest semicircle equals to x plus y over 2 units in its length. Likewise, the radius of the medium semicircle equals to x over 2 units in its length. And then radius of the smallest semicircle equals to y over 2 units in its length. We know that the area of a semicircle equals to pi times the radius of the circle squared. Yeah, the area of any semicircle equals to pi times the radius of the circle or semicircle squared over 2. Therefore, the area of the biggest semicircle must be equal to pi times the radius of the semicircle squared, that is actually x plus y over 2 squared over 2. Likewise, the area of the medium semicircle must be equal to pi times the radius of the semicircle, that is x over 2 squared divided by 2. And finally, the area of the smallest semicircle must be equal to pi times the radius of the smallest circle squared, that is y over 2 squared over 2. In the next step, we simplified all those three expressions. So here we have pi over 2, and we have x over x plus y over 2 squared. We open the brackets here. X plus y squared equals to x squared plus y squared plus 2 times x times y over 2 squared. 2 squared is 4. Likewise, we have here pi over 2 times x over 2 squared. X over 2 squared equals to x squared over 4. Here we have pi over 2 and y over 2 squared is y squared over 4. So here we have, on all those three expressions, we have 8 in the denominator. We have 8 in the denominator on all those three expressions. 2 times 4 is 8, 2 times 4 is 8, and 2 times 4 is 8. So we took 8 as a common factor out of those three expressions. And here we have in the denominator pi times x squared plus y squared plus 2 times xy. So we open the brackets here. It is pi x squared plus pi y squared plus 2 pi xy. And here we have minus pi x squared minus pi y squared divided by 8. Pi x squared minus pi x squared is 0. Pi y squared minus pi y squared is also 0. So all those four expressions will get cancelled. All those four expressions will get cancelled. And we left only 2 times pi xy over 8. So they have this same green shape equals to 2 pi xy over 8. We have divided both the numerator and the denominator of this expression by 2. So here 2 over 2 is 1, so we left only x times y, then with pi times x y in the numerator. 8 over 2 is 4. So in total we found out that they have the green shape equals to pi times xy over 4. So it is pi over 4 times xy. But we already found out that xy equals to 4. So we can substitute xy by 4. Substitute xy by 4. And finally found out that the green shape equals to pi times 4 over 4. We have 4 in the denominator, 4 in the denominator, so 4 will get cancelled, we left only with pi. So we should find out that the area of this green shape, that is the area that we're looking for in this question, is equal to pi square units in its size. Okay, again, the area of this green shape, in total it is equal to pi square units in its size. Okay, thank you very much.